All right, so we're going to do this lab on OSPF. We got three areas. We have already decided the IP address on the physical ports. For the loopback interface, I'm going to use the router name as the address. For example, router 4 will be 4.4.4.4. Router 3 will be 3.3.3.3. The loopback. So I have not written here the loopback interface information on the board. Interface loopback 0 IP address is 2.2.2.2 on router 2 and 32 mask. And on the physical interface, IP address is 10.234.0.2. And I would like to enable OSPF straight away here. IP OSPF 1 area 20, so 10. Likewise on this interface here, IP OSPF 1 area 10. This type of lab we have already done, isn't it? The basic lab. Now I'm going to end this and write to memory, and I'm going to put this on the command prompt for router 2. Done. After this, I'm not going to go to router 3 or 4. I'm going to sniff this with Wireshark. That's the important learning. Start capture. Router 2 is gig Ethernet to the switch, yes. So what do I see? I see a multicast traffic, you see? You know very well that other routers are in shutdown state. But the switch is up. Ethernet 0 switch is up. So the line protocol runs between router 2 and router 1. If the link is up, line protocol is up, OSPF will start sending hello packets every 10 seconds. If you see here, approximately 10 seconds it has taken. You see 9.3. This is 0.0. Again, next hello, if you see 18.3. Exactly 10, isn't it? 18.3. Okay, let me show you only the OSPF packet. This is how you can filter. And if you see the time difference, it's only 10 seconds. Okay. Capture, no. Protocol, advance, no. Statistics, protocols. In view, I can layout. Layout is okay for me. Layout is okay for me, but what I'm trying to show is not here. I can calculate and give you the time in a separate column. No problem. That's taking time. I'm going to do what? I'm going to show you in detail. I can zoom here. Okay, so I'm picking up one of this packet, OSPF packet, and I'll show you. Look at this. Layer 2 We need to see everything. Layer 2, destination address is a multicast address. If you see 5E here in the middle, it is multicast. And also you see 224.0.0.5 is the multicast address, layer 3 multicast address. Layer 2 also have got that same 05. If you see E or 5E, it is multicast always. And 05 is for OSPF, layer 2 multicast for OSPF. And this is the MAC address of the router which is sending this, that interface gig 3/0's MAC address. And now this is simply nothing but IPv4 is the next header, next layer. So here you can see IPv4 layer. Source IP address is this, the one who is sending, destination IP address this. Now what is he sending? He's sending an OSPF packet. You see OSPF IGP 89. 89 is the protocol number for OSPF. And then how much the packet will be valid? It is only valid for one hop. TTL is only one. Don't forget these things. These are all very important things which many people do not know. The packet goes only for one hop. That's all the validity is. So it cannot form neighbor with some 5 routers away. It goes to the next hop and then vanishes. And this is the source and destination multicast. Now let's go to the OSPF's field. OSPF has got a header, hello packet, LLS. Let's open the header. You can see version 2 means IP version 4 OSPF is version 2. IP version 4 OSPF is version 2. And this is type 1. You remember we learned 5 message types in OSPF. One is hello packet. Type 1 is hello packet. What is type 2? What is type 2? Good. Type 3? Yeah. 4, 5. Very nice. So far in our capture, we don't have anything other than type 1. Why? First of all, it has to form neighbor, only then it can send a DBD or LSR or LSUs. So for no neighbors, we just configured only one router. So it'll be keep on sending hello packets, and you see the length of the hello OSPF header is 44. This is not the total packet length, it's the OSPF. Okay, so the total length you can see here 76. And then you can see the source, the router ID. So this source is different from layer 3 source. This is the original source of the packet. But this is the router ID talking to another OSPF router. If there is another OSPF router, it will take this as the source, the router ID. With this only you will see forming neighbor. It will say my neighbor is to that. Who will say? The other routers. It won't say my neighbor is 10.234.0.2. Though packets are coming from there, OSPF will only use the router IDs to speak about. The area ID is also 32-bit. It will be in this format, like same IPv4 format. And because I said area 10, it is like this 0.0.0.10. And now there's no authentication enabled. Let's do one thing. Let's see if I give area 500, how this looks, how it changes. So I'm going to say area 500. I change to area 500 and I'll paste it here. Yeah, we have changed. Now let's capture the latest one. Let's see the latest one. Okay, look at this. This is how 500 can be written in the 8-bit, 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 8-bit format. How this is 500? See, if you have one here, it is 256. Up, the what is the maximum here? 255 is the maximum, isn't it? If this is 255, then the next bit will be 256. So 256 plus 244. What it is? Yeah. And then no authentication. And let me close this. Open hello packet. See, in the hello packet, it also advertises the mask. So if anyone wants to form neighbor, first the mask should match. Mask must match. Next, the timer should match. Priority doesn't matter, doesn't need to match. That timer is 40 seconds. There is no DRBDR so far elected because this is the only router we enabled. And you see the flag values. This is capable of forming neighbor with, means this is capable of carrying external routes, meaning if someone redistributes some other routes into this OSPF, it can carry. All right. Other things are zero, means it is not included. LLS is default. Now, the default priority is this. So the link length is like 12 bytes. Extended option. TLV is type length value. What do we see here in TLV? Nothing so important here. Now, because we don't have much updates, you don't see any. In hello packets, only this much you can see. You cannot see DBD or anything related to link status. So I close this. Now, that's hello packet. I remove the filter. Now you can see all packets, including OSPF. But still, let us keep the OSPF filter on, OSPF, and then we move on to the next router. We move on to the next router. Next router, I would like to configure router 3. And this is going to be 3. No, router 3. Yeah, okay, we will change it as area 10. No, it's okay. Then I need to go and change router 2 also. Let's make it as 500, okay? Is it okay? Okay. So now router 3. Right. If I put here 10, then it will not form neighbor, the problem. Fine. Now let's see if any hello comes from dot 3. It's still dot 2. So not even a single hello has come so far. I'm waiting. Router 2 has not received any hello from the other side. Only dot 2 I'm seeing. I'm expecting from dot 3. This router should receive hello. Oh no, I will not see. You know why? Because that is sent to 224.0.0.5. So here it is seeing only the one which is sourced with this address. I would like to see. Um, I want to put a filter. Uh, IP dot address, and then let's put equals 192.168 dot. Sorry, is it 192? No, 10 dot. 10 dot 234.0.3. So from this source, I didn't see any packet because I'm not capturing there. I'm capturing here. I'm capturing here. So when it comes here, the packet will not have. Why not? Why not? It should have. Maybe the interface is down. Is it down? Let's go check. Show IP interface. Show IP OSPF interface. OSPF is running 10.234.0.2. Aha, this is the problem. I'm not able to ping here. That's why I didn't receive any packet there. Why is that? Oh, here it is 4/0. That is why. Did you find the mistake that I have done? Did you understand the mistake? Yeah, yeah. Now when I put the IP address on this interface, I'll get what I need. Okay. Now I should see all the packet source. You see, this is the one which is sourced from .3. Now when I click on this, oh, even the DBD, everything started coming. But I want to see only the hello packets. How do you filter only the hello packets? Hello packets from anyone. So I want to see all the hello packets coming from all the neighbor. See, you should also learn this. To filter hello packets, I just need to drag and drop it here. That's it. It will show me only the hello packets. You see. So I did not write this filter by breaking my brain like ospf.message.equal=1 type 1. I did not do that. I just drag and drop it. I can see hello packets coming from .3 as well as .2. Let's go to .3 and see. .2 we have already seen. .2 we have already seen. .3, what do you see? It says the router ID is 333 and the mask. This is very important to know. And then look at this, the DRBDR. Router 2 was configured by us long back. So that is DR. The one which we just enabled is BDR. So the active neighbor for this particular 3.3.3 currently is 222. And now, what else I want to show you? Okay, the type 1, this is still type 1 only. Hello packet. Let's do type 2. Say I'm just going to change number 2 here to see DBDs. These are all DBDs. You can see the information here, DBD, database description. Now this DBD is coming from router 2 going to router 3. Please focus. Is DBD multicast? No. DBD is a unicast. After knowing your neighbor, you send the packet to the neighbor. It's unicast. Do you see 224.0.0.5 here? No. Okay, it is type 2, and then coming from the source. Now in DBD you will find some information at the bottom. If you go here, okay, close this LL. Yes. Now go to DBD description. I want to close the header. DBD description. Okay, the empty size is 1500. If the empty section is not same on either side, then this DBD cannot be sent. So it will be in two-way state. This is the reason why empty size should match. And go down, open this description. Okay, it's not init. Extended options. Let's pick another DBD which came recently. Okay, remember we learned LSA type 1. Type 1 LSA is sent by every single route. So this router is sending type 1 LSA advertisement. And it is advertising about the link state 3.3.3.3. Now who is the DR? R2 is the DR. Now where I am in router 3 sending to router 2. Router 3 sending to router 2. Let's see router 2 sending to router 3. The DR. Unfortunately, I don't see here. Maybe it shared already the DBD on the top with the link state info. So DBD, the one which is the DR one, which is the master, will be using 224.0.0.5 to announce this. That portion we are not seeing because it's not using multicast. I filtered like this. I should now filter like this. OSPF dot. Now let's say I'll just put here 224.0.0.6 is 2DR. 2DR, what has been sent? Nothing? Okay. 5. Okay. These are okay. Hello packets. I don't want to see hello packets. Do we have any DBD? Yeah, here we see. No. 5 will be used by the DR to send to others. Okay. 5 will be used. 6 will be used to talk to the DR. 5 will be used by the DR to send updates. You see here, this is DR, the sending update, and open the update packet. Okay, it is giving information about the network 2.2.2.2. See the sequence number of OSPF. You remember the sequence number. Every change it happens, this will get incremented. And look at this. This is the network it is advertising. It says that this particular link is a stub, meaning it's a loopback, meaning it's not connected to any other router. That's why it is stub. Transit means it's a router's interface. right? So these are all the informations that are shared in the OSPF update. We need to be clear with this thing. It shows the link ID, it shows the meaning link ID is nothing but the IP address of the link. It shows the subnet mask, and stub means there is no other way to go to the remote network. Can you go to some remote network via loopback interface? Answer. Can you go to any destination via loopback interface? That is stub. Whereas transit is opposite. Transit is you can go to any some destination via physical interface, isn't it? So type 3 connected to stub network means you don't have anywhere to go via that link, but via this link, type 2 link, you can go to some destination. That is what it means. And also it is advertising the cost according to the bandwidth. The cost is this. Now let's do one thing. Let's go and change the cost of this link 22222 and see whether that cost is getting advertised as an update. Right now I am going to go to router 2 loopback to set some cost. Interface loopback 0 IP OSPF cost. I'm going to say 100. Look at this. As soon as I hit enter, immediately an update is sent by the DR. You see, this is sorry by the DR other. Sorry, this is DR itself. So it is using 224.0.0.5 and acknowledgement is sent by router 3. Router 3 says I received it. Now let us open that update only now. Look at this. The metric of this is 100. 2222. Earlier it was only 1. Now let us see how the acknowledgement looks like. Router 3 says I received it. Router 3 should say I received you. Your update. Okay, it's just an acknowledgement with the sequence number. With the sequence number, it is sending the acknowledgement. You see the older one. For this, the sequence number, if you go down, 3. For this sequence number, router 3 is sending an acknowledgement. All right, this is an add packet, acknowledgement packet. How do I know? If you open here, you will see it's type 5. Yeah. All right, so let us now move on to the next study, next level. We have seen the packet types, the message types in OSPF. I'm going to stop the sniffer here, quit without saving, and we'll configure router 4 now. All right, G3/0 will have 4 here, and it is area 500. Even the loopback of router 4, I would like to put it in area 500 only, but interface G4/0 should be in area 0. IP space address 10.45.0.4 0 IP OSPF1 area 0. This will go on router 4. Now again the neighbor will come up with router 2 as a DR. Let's go verify it. Show IP OSPF neighbors. And you can see router 2 is the DR, router 3 is the BDR. If you refresh OSPF, there are chances that router 3 will become a DR because it is in the sequence. When you reset, the previous BDR will become DR. Yeah, the previous BDR will become DR. Or if you leave it for shutdown like 40 seconds, all the neighbors will get expired, and then when you start, then you will see router 4 becoming DR because of the big router ID. All right. Now let's take 5 minutes break and then we'll continue this. All right. So we have enabled OSPF on this 3 router, and they form neighbor. Let's go change the priority and see whether the DR BDR role will change. Tell me, will it change? No, because DR BDR election is non-preemptive. If you want to change the role according to the latest configuration like priority, then you need to reset the OSPF. You need to clear IP OSPF process. Let me do and show you interface gig 3 slash IP OSPF priority. I'm going to say 100. I want this to be the DR, so I give 100. You can give up to 255. Now I'll go to router 3. Here, interface G 0/4, I believe. 4/0. 4/0. I say IP OSPF priority 0. What does this mean? This should not become either DR or BDR. It should be DR other only. That's what I want. And router 3, I want it to be a BDR. So I'll say IP OSPF priority 99. Yes. Okay. Interface G 3/0. Done. Doesn't matter. That is in the other direction. This is per link. Election is per link. Now, clear IP OSPF process. And I should say yes. I'm not going to say yes now. I'll just keep it ready like this. And then clear IP OSPF process. And then here, clear IP OSPF process. Okay. Now I would like to start from this, and this. Okay, I'm expecting a re-election. Let us see. If I go to router 3, I should see router 4 as a DR and router 2 as a BDR. Let's verify. Show IP OSPF neighbor. Yes, as we expected, router 4 is the DR and router 2 is the BDR. Router 3 did not take these roles because router 3 is having priority 0. You can see that by going to router 4 or router 2. I'll go to router 4 and show you the same. Show IP OSPF neighbor. Because of this priority 0, it will never be a competitor. It will never participate in the election. Done. What is next? Now we are going to configure R5. Plus. All right, so R4 is already ready with configuration. Let's go to R5. PSCR for show IP OSPF interface brief. I have even configured the other side, area 0. So I want to go to router 5 side. Router 5's loopback, I would like to put in area 20. And G3/0 will have 45.5. And that is in area 0. And the other side is 56.5. Right now, that's right. Serial 6/0. Okay. Now I'm going to paste this on routers. Area 20. Router 5. Now this is for router 6. Router 6 has got only one interface. Physical, only one interface. Logical, one interface. And this is 6. Yes, it's your wish. So router 6 is completely in area 0, sorry, area 20, so I put all the interface in area 20, and I paste here. Now I'm expecting neighbor. After this, I would like to show you the neighbor status. There won't be DR or VDR because it's serial. Show IP OSPF neighbor. It is serial. So the default priority on serial interface is 0. Even if you change the priority, it is of no use. They won't consider priority. Let us see the hello package that is going on serial interface by capturing. Serial, okay, no problem. I need the size, okay. Now this is the hello packet coming from router 6. It says I belong to area 20, and then hello packet. It sends the mask, and then it has got router priority. This is not the priority on the link. Let's go and check on the linkage. See, the priority of router 5 is 0 only. From where the packet is coming, it's coming from router 5. So don't consider this one. It is 0 only. And there is no DR BDR. See, no backup designated router. Let us now go to, all right, this is enough here. Close this. Now, I would like to show you this command, show IP OSPF interface serial 6/0. There you can see the network type is point-to-point. When the network type is point-to-point, there will not be a DR or BDR. Okay, so this is the process ID. And do you see any priority mentioned here? The timers are 10 and 40. There's no mention about priority because it's serially. Okay. Now, that's not the case on router 4, on router 5. Let's go to router 5 and see the other side of the interface. Other interface, like gig Ethernet interface. Router 5, gig 3/0. Not here. IP OSPF. Show IP. Interface gig 3/. Here you can see the network type is broadcast, and then you can see the priority also. Whereas on router 6, you don't see any priority mentioned anywhere. On the Ethernet links, you will see priority. Disconsidered. If you change priority, there will be some impact. Whereas in serial, even if you set it is not going to come here, so it's of no use. All right, now you see between router 4 and 5, there is only 2 links. There's only 2 participants. Router 4 and router 5. There is no need for DR/BDR. 4 is elected as DR and 5 is elected as BDR, which is not needed. We can make it as point to point. So I'm going to change the network type as point to point. You remember we learned in NBMA also point to point. I'm going to do this interface gig 4/0 IP OSPF network type point to point. I'm just switching from this broadcast to point to point. Sorry, not 4/0, 3/0. Interface is 3/0. Let's see. You see, interface 3/0. IP OSPF network type point to point. So when I do this, I'm saying I don't want DR/BDR election. Now let us go back to that interface command and see G3/0 again. You see, I made it as point to point, so no priority again. Even though it's a gig Ethernet, even though it is Ethernet, because I changed the type as point to point, there is no DR/BDR, no priority. There is no mention about DR/BDR. Earlier, the same interface was having priority, was having BDR/DR, but now you don't see that. We'll also go to router 4 side and configure the same. Interface G within 3/0, am I right? No, 4/0. IP OSPF network type point to point. So now let us check whether there will be any DR/BDR between these two. Show IP OSPF neighbor. You can see that between 5 and 4 there is no DR/BDR because the network type is pointed. Right, the other side we have finished already. Let us now ping between router 2's loopback to router 6 loopback. Ping 6.6.6.6 with the source to that. You are able to ping. Yeah. So are you comfortable? Did you enjoy this lab? Do you like this type of learning? All right. So this is how the real learning happens. You will really understand the in-depth if you learn like capturing. So we'll continue doing this good thing, and